Hello, my name's Brian Energeski, and I'm here to help security operators or SecOps learn how to perform practical AWS CloudTrail analysis for their AWS accounts. At AWS, I help navigate customers on the customer side of the shared responsibility model and how to triage and recover from their security events on AWS. This includes both my experiences with customers and navigating them through their security events with CloudTrail, and my prior experiences in AWS customer in security engineering and operations, where I was defending national security systems, privacy, and healthcare data on AWS. In this session, we're going to explore how AWS CloudTrail as a service has value for your security operations. We're going to dive deep on sources of data enrichment and then how to leverage that CloudTrail as part of your security operations and incident response procedures. We're also going to review a common scenario that I see, which is crypto mining currency from an unauthorized launch. Before we deep dive, we're going to go over what CloudTrail is and what it does. Understanding the record format and the different types of fields that are within there and how it performs is critical for that search. AWS CloudTrail helps you discover and troubleshoot both the security and operational issues by capturing a comprehensive history of your changes that occurred in your AWS account within a specific period of time. These service events are authenticated and then captured as CloudTrail events, and these events can then be accessed by the CloudTrail console by region, stored in the S3 bucket, or Amazon CloudWatch logs. These captured AWS service events become CloudTrail events, which then are delivered to the AWS CloudTrail console. When we look at CloudTrail for security operations or SecOps, we look at the CloudTrail as an audit log request to the AWS service APIs, or as we also call it, the control plane. This allows you, the security operator, to gain visibility into user, service, and resource activity, and also troubleshoot security and operational issues. More importantly, once you learn this format and the syntax of the CloudTrail event with the AWS services, you can then build detective security controls and then work toward automating their response around important CloudTrail event activity that your organization considers to be an unauthorized action in your AWS account. As an audit log, CloudTrail captures all the authenticated user or AWS service actions made against the control plane. This includes read and write actions to the AWS API, including created, list, describe, modify, and delete API actions to an AWS service and its resources. This becomes available within 15 minutes with your AWS account in 4 different ways. You have the CloudTrail event history, which is available in the management console for up to 90 calendar days per region. If you configured, enabling the CloudTrail trails that will log the data, which can go either to S3 or CloudWatch logs. You also have Amazon Event Bridge, as the events can be filtered as a trigger for further action if it's configured by yourself, the customer, for detective controls. And then it can be ingested independently by AWS security services if you enabled. A common example is Amazon GuardDuty, which will use CloudTrail for some of its detections, and then Amazon Detective, which will ingest those to build the behavioral models. It's important to understand those differences in the CloudTrail event history, aka the CloudTrail console, versus an organization-configured CloudTrail trail. Asked by customers during their event, what's the difference between these significantly. Both are useful for SecOps, but they have their different purposes. The CloudTrail event history, aka the CloudTrail console, has the advantage of always being available as a read-only per region for the last 90 calendar days. It does have a limited search fields that are available, and you can only search one region at a time with the CloudTrail API. To access that API, you can either do it through the Amazon Management Console or the AWS CLI. CloudTrail Trail, when you configure it actually in the AWS account, can extend past those 90 days as an archival log. It can be multi-region, and then you can aggregate one-to-many accounts into the same S3 bucket for archival if you choose to do so. Native AWS services like Amazon CloudWatch logs, Insights, Athena, you can use those to aggregate and review those logs as you need to, and in addition, using third-party software. Once you have that event history, you have those two outputs, S3 and CloudWatch logs. S3 will, when it takes that log, it will aggregate them together and then push that series of logs as compressed logs in the GZ format in a JSON. For CloudWatch logs, it will take each of the CloudWatch events and make it a log event in CloudWatch logs against a log group, which then you can use insights or just standard CloudWatch logs to search. If you choose to configure it as a trail and into S3, you have the ability to use Athena to query those from your S3 bucket as SQL statements. And if you have it as CloudWatch logs, you have the ability to do your search and analyze from its syntax of search, which is similar SQL-like. In addition, from those 2 ways to deliver, there's over 20 different partner integrations for operational security solutions that will connect to these 2 different resource types for further analysis. Next, we're going to go over the anatomy of a CloudTrail event. In these particular slides, I'm going over things that I find to be critical during a security event, of where to focus, and then kind of describing critical parts of that CloudTrail event record, what you should be focusing on. When I do a hunt, I look at the CloudTrail event fields in these 5 distinct groups of what I deem as critical fields. Each of these fields are part of a CloudTrail event record. Some of these are required fields, and that depends on the version of CloudTrail produced by an AWS service, and this can change over time. The link at the bottom of the slide contains what the current version and what required fields are. In this kind of search, I look at the who. So in a who, I'm looking at the user identity yarn, which is a string that contains the AWS account number, the type of IAM entity that is being done, and it's also the role that's being done. The source IP address is what the control plane sees as an IP address, if this is from a public IP or an internal IP within your VPC. In addition, it's also capturing a user agent. This is based on what client is accessing the API, either as the AWS CLI or an Amazon SDK. For the what, the record will capture the account ID, the event source. The event source is going to be an AWS service, typically a name, short id.amazonaws.com, event name, and then the request parameters of that request to the control plane or the Amazon API. When this request is made, it is recorded as an event time in UTC format, and the region that was accessed from the control plane is also recorded as part of that record. In the how, this records the event type. The event type is the action that's made against the control plane. This also will include the user identity type, the access key ID that was used, either as a ACA or ASIA key. We'll go over that a little bit in a minute. And the user identity that was, if it was invoked by another service or another other service. For the result, when this request is made to the control plane, an event ID is generated, which is a unique GUID to identify it within the region, within the account. If the action was not authenticated or it had an issue against the control plane, error code will generate. Or if it is successful, it will generate response elements to give confirmation of what it did. If we're talking about multi-account events, we talk about shared event ID, which we're going to describe and go through further in later slides. Once you understand that the service event types, there's also very distinct categories of event types. There's management events, which are enabled by default. Those record all the control plane operations that are performed on or with a resource. There's also data events, which are not enabled by default. These can record with certain supported AWS services like Amazon S3 and also Lambda, which will record their execution. In particular for S3, it records the object events, which are typically not recorded in the CloudTrail when you're looking at a control plane. There's also the additional enablement that can be done. It's called insight events. These are not typically enabled by default. And what they'll do is they will go through your CloudTrail, they'll look for write events, and they'll look for unusual call volume of that management API. in your AWS account for 90 days. This is good for behavioral monitoring, but it was originally designed for operational use. From a security operations perspective, this can be an early leading indicator of unnormal activity that's occurring in your AWS account. Now that we've described that general overview, we're going to start deep diving in certain sections of the CloudTrail event record. The user identity object is the most complex object that's within the CloudTrail record. This will record a user identity type and an access key ID that's used. It will record the principal who made the request, which is captured in user identity yarn, and then user identity principal ID, which is a unique identifier for that principal. Also capture the friendly name. Friendly names are more for logs and users of the API. The principal ID is more the unique identifier, in this case for a search. And then most importantly, the AWS account that it was made from, which is the account ID, which helps when you start talking about cross-account access. If temporary credentials were used, you're also going to get a user identity session context and user identity session issuer. And we're going to go over some examples that amplify this. And if you're using a AWS service that was invoked, that's captured as a separate field, which is the invoked by. Further information is included on the link on this slide. We're going to go over two critical examples that I find customers ask me about. One is an IAM user access key. In CloudTrail, this is what we call an ACA on the access key ID, which is highlighted in yellow and underlined. That in particular is a access key that is assigned to an IAM user. It is a static key that exists when created or deleted from a user. The other one that I find customers have issues is a console login. When an IAM user exists and does a console login, it actually accesses the STS service, creating an ASIA key. And that ASIA key, as we described before, was going through creates a session context. That session context will let us know if MFA was used, and then the creation date of that session, in this particular case for a login to the console. The other two is with the STS service, which is around role assumption. There's two ways this can be executed. Either as an IAM user or another STS access, where you're assuming a role in order to perform an authorization decision. Note that the access key is still ASIA, and then note the user identity ARN contains the account number, the type of action that's occurring, which is assume role, name of the role that's being used, and then the session name to that role to form that user identity. For an EC2, aka an EC2 instance role, that will use almost the same type of format, but note the difference is the session name is typically going to be, unless defined in the CLI or the SDK, it's going to be the instance ID. Also note it's still in Asia because it is a temporary credential. When we talk about cross-account, we also have to look at the different fields that identify what a cross-account occurs. Per this diagram, we have a dev account that is accessing a prod account, assuming a role in the prod account. And then we're looking at the CloudTrail events that occur in both those accounts in order to determine what happened. Both of those accounts receive their own unique request ID and event ID per account, per region. Both of them will have a shared event ID that is the same in both accounts to be able to tie those two records together. The user identity account will be the source account in both those record sides. In addition, what will differ is the recipient account ID. For the source account, it'll show us a source account. However, for the destination account, it'll show us a destination account. And that distinction is very important. Now that we stepped through those different sections of the CloudTrail record, we're going to step through a light scenario that we mentioned before about cryptocurrency mining from an unauthorized EC2 launch. For our scenario, we have a DevOps team that identified unusual EC2s being seen in US West 1. However, this DevOps team typically operates in US East 1. Guard duty has been detected, the same EC2s in US West 1, querying an IP address that's associated with cryptocurrency-related activity. And in addition, an AWS abuse notice has been issued that one of your IAM access keys has been compromised prior to these EC2s being launched by your DevOps team. Now we're going to start going through and figuring out how we're going to use CloudTrail to do that analysis. Before we start that hunt, there's key enrichment sources for your CloudTrail events you can use to aggregate against these events. Typically, when I'm performing these hunts on a customer's behalf, I'm looking at GeoIP attribution, which is against a source IP address. That lets me know the ISP and any geographical IP network usage that can occur when it's non-AWS IP address or an internal private IP. As mentioned before, Amazon Guard Duty is also another enrichment and detection source. That will detect known threats from the threat intelligence and unknown threats with anomaly detection from its monitoring of CloudTrail. This can help accelerate your analysis considerably because it gives you a starting point and an absolution of a behavioral or a known threat that's detected with Guard Duty. Another enrichment source which is undervalued by a lot of customers that I see is AWS Config Recorder. AWS Config Recorder, when enabled, will go through and baseline all your AWS accounts per region to the resources you enable, to the resources that it supports, and it gives a timeline history and records of all changes that have occurred in those resources. When you work backwards from this configuration state, you can start help building your timeline analysis. Now that we established the enrichment sources and the scenario, we're going to start figuring out how we're going to do this hunt. So what are our desired outcomes in this? We're going to identify whom and what executed those EC2 launches outside our typical operational region of US East 1, because we know they're in US West 1. We're also going to explore why AWS Abuse provided a notice against the IAM Access Key. Right now, we don't know if these are interrelated. It is a hypothesis that these are interrelated. In this hypothesis, we're going to try to prove that this IAM access key is related to these EC2 launches, and then we have the additional data set of guard duties detection saying there's cryptocurrency mining coming from these instances. Using a work backwards approach, we're going to, with that interrelations, we're going to first investigate the event type run instances for the unknown EC2 launches. This will give us additional details from the CloudTrail record events of how those instances were executed. And then we're also going to look at the user identity access key provided by the AWS abuse notice and see if these two are interrelated. Once we look at the CloudTrail record, we review the event name from their event source. We identify the key user identity ARN of interest to profile that behavior. Since all actions against the control plane API are authenticated and as a request, that user identity ARN gives us a lot of detail to build a timeline analysis and behavioral analysis against that ARN. Once we look at that ARN, we want to separate into read-only, which is a field of types. Read-only is a newer field that has been added to CloudTrail in the past few years. It's becoming more and more used by several AWS services to find a read-only versus a write action for an AWS service. At the time of this recording, it is not a required field. Once we look at separate those into the two different buckets of types against the user identity ARN, we start evaluating the source IP address and the user agent as a combination of uniqueness to the changes of times of identity. We are doing a very basic behavioral analysis to determine did something change on this user identity ARN that made an unauthorized access decision. Once we start looking at identity ARN and we start looking at that source IP and user agent combination differences, then we look at the change of the behavior of the service usage across those regions. Did this user identity ARN use only US East 1? Or did it use AP Southeast 1 or other regions? If we're noticing that that's not occurring, then that's a different story. Now we start looking at event time to produce a timeline of events for each of these user identity ARNs. The timeline is going to be critical because it's going to start establishing behaviors of that user identity ARN, especially if it belongs to a console user, where they're typically going to have certain patterns of when they log in for work, they access the console, and then they sign off for the night using certain ISPs or networks. Once we have some of that data together, I typically like to use some key summary fields to search across the AWS services. When using these fields, it allows me to establish a baseline of that activity. You'll notice a lot of these fields are the same from the prior slide of the critical fields, but narrowed down a little bit further. The critical part is, and which I find that most customers tend to ignore, is the error code and the error message, which can kind of give you critical data when an unauthorized decision has occurred, and then can be separated as if it was an attempt for authorization or if it was a lack of access rights. Once we've gone through that, we can review the guard duty findings, detectors in the region. And I provided a link to the different types. In this particular type, we're looking for crypto mining currency finding. Once these events of interest, we can begin to pivot and add fields. Once we find that particular run instances event, we can start looking at the request parameters that was used, that was sent to the AWS service. In this particular action, you're typically going to see the AMI used, any type of security groups, if it had a public IP launched. And then the response elements, which will give the success of that action. In this particular case, for run instances, it's going to give a instance ID back. Once we start doing that hunt, we evaluate all the regions for read-only false for 1 week. We know where the run instances occurred. We know where the guard duty event occurred. And now we start walking backwards and looking back at when was this access key first used. We're more concerned about if there was additional reconnaissance performed or if there's any other additional mutating actions against AWS services. Now that we have the user identity ARN, we're moving back at least a week. We start pivoting on that user identity ARN for the prior activity to the event name. Once having that event name, we look at the source IP address and user identity, or again, that's uniqueness to that identity behavior. And then we start looking at if there's anything that's related to the source IP addresses used by additional identities across that data set. Well, I hope that you enjoyed my presentation. There's additional presentations that help augment this. There's SEC 301, which is the Security Investigations Amazon Detective. Remember, that's one of the AWS security services, when enabled, will ingest CloudTrail and look for behavioral anomalies. We also have SEC 306, which takes CloudTrail and adds it as part of automated forensic artifact collection. So it's using the events out of CloudTrail to determine certain things should occur, and then how to isolate those and then extract forensic evidence from those EC2s. And then we have SEC 307, which is using Amazon Guard Duty and Security Hub to secure multiple accounts. Again, Guard Duty does ingest CloudTrail for its detections, whereas AWS Security Hub is looking at AWS config and its various rules for how to do that security to a baseline. Hope you enjoyed my presentation, and thank you for your time.